The Leaning Tower of Pisa is a famous landmark. People all over the world know it. It is famous for its tilt. Construction on the tower started in 1173. It was supposed to be a bell tower. It is part of a cathedral complex in Pisa, Italy. The tower started to lean during construction. This happened only 5 years after they began building it. The lean got worse over time. By the late 20th century, it was in danger of falling over. People were worried. Would this beloved landmark collapse? The Leaning Tower's tilt was caused by the soil. The ground beneath the tower was not stable enough to support its weight. The foundation was not built on solid ground. Instead, it was constructed on a mix of clay, sand, and other materials that shifted over time. The soil under the tower is uneven. This unevenness caused one side of the tower to sink more than the other. The north side sits on softer ground. This softer soil couldn't hold the weight of the tower as effectively. This ground is mostly sand. Sand is not a stable material for heavy structures. The south side sits on clay. Clay, while more stable than sand, still posed challenges. Clay is more stable than sand. However, it can still shift and settle over time. The foundation itself was also a problem. It was not deep enough to reach more stable ground layers. It was only 3 meters deep. For a structure as tall and heavy as the tower, this was insufficient. This shallow foundation, combined with the unstable soil, made the tower lean more and more. Over the centuries, the tilt became more pronounced. By 1990, the tower was leaning dangerously. It was at risk of toppling over completely. The Italian government closed it to the public. This was a necessary step to ensure the safety of visitors and to begin restoration efforts. Over the centuries, people tried to fix the lean of the Leaning Tower of Pisa, a marvel of medieval engineering. Some builders tried to adjust the upper floors by making them taller on the shorter side, hoping to counteract the tilt. They meticulously measured and adjusted stone blocks, adding height to the shorter side. However, this did not really work as planned. Instead of straightening the tower, it gave the structure its slightly curved shape, which is now iconic. The tower's unique curvature became a defining feature, but the lean persisted. In the 20th century, engineers tried to add a concrete foundation, believing that modern materials could solve the ancient problem. They thought this would help stabilize the structure and prevent further tilting. But the heavy concrete made the lean worse. The added weight increased the pressure on the unstable soil beneath the tower. This additional pressure caused more soil erosion, exacerbating the problem. By the late 1980s, it was clear that something drastic had to be done. The tower was dangerously close to collapsing. Emergency measures were put in place to support the tower and prevent a disaster, marking a critical moment in its history. A group of experts came up with a detailed and innovative plan to save a historic structure. They decided to use a method known as soil extraction, a technique that involves removing soil from specific areas to stabilize the structure. This meant carefully and meticulously removing small amounts of soil from under the north side of the tower, ensuring precision at every step. They drilled small angled holes under the foundation, a process that required both skill and advanced technology. Then they carefully removed the soil, bit by bit, monitoring the tower's response to ensure stability. This meticulous process allowed the tower to gradually settle back into a more stable position. To further aid in the stabilization, they placed large lead weights on the north side of the tower. These weights acted as a counterweight, providing additional support to counteract the lean. In addition to the weights, they installed strong steel cables around the base of the tower. These cables were crucial in reinforcing the foundation, ensuring that the tower remained stable. Lastly, they added an advanced drainage system to manage the water table around the foundation. Too much water under the foundation could exacerbate the lean, so managing water levels was essential. The result of these combined efforts, the tower was straightened by an impressive 38 centimeters. It was a remarkable success. Thanks to modern engineering, the Leaning Tower of Pisa was saved for future generations to admire.